Hi everyone, today I'm going to introduce you a new concept that is called logarithmic function. And it can also be called as inverse of exponential function. Sorry, I spelled wrong here. So, if you know something about a function f, and you will automatically know a little bit about its inverse, that is f inverse. So let's start with the exponential function. F, that is y equals to 2 to the x power. And then if we interchange the variables x and y, we can obtain the inverse of f, that is x equals to 2 to the y's power. And this new function is again given a name, logarithmic function with base 2. And it is also symbolized as follows: y equals to log 2x. Thus, it means this new defined function is equivalent to the inverse function, that is x equals to 2 to the y's power. Now let me show you the graph of the original function f and its inverse function. And as we know that the graph of the inverse function is exactly the graph of the original function reflected the line y equals to x, and the domain and range of the inverse function are respectively the range and domain of the original function. So next is the graph of the both two functions. We will have the y-axis first, then comes up with the x-axis. Now we will draw the line y equals to x first. Then comes up with the original function, which is y equals to 2 to the x power, and it should be like this. And the inverse function, we can denote it as x equals to 2 to the y's power, or by the new definition, that is y equals to log 2x. And the graph is like this. Obviously, we can know that the original function and the inverse function are symmetric along the line y equals to x. Now let me tell you more something about the relationship between the original function and the inverse function. We can have the x in the original function increased by from 0 to 1 to 2 to 3, and we can have the y equals to 1 if x is equal to 0, that is, and if x is equal to 1, we can have 2, and x is equal to 2, we can have 4, and if x is equal to 3, we can have 8. So how about the inverse function? We can have the y increased from 0 to 1 to 2 to 3, and the inverse function is 2 equals to 2 to the the x equals to 2 to the y's power, that is, similarly we can get 1 here, 2, 4, and 8. So from this we can see the relationship between the original function and its inverse function. And in general, we usually define the logarithmic function with base b to be the inverse of the exponential function. And the condition is that b should be larger than 0 but never be 1. So for b larger than 0 but never be 1, we can get y equals to log bx, that is equivalent to x equals to b to the y's power. Here we have two examples. First is y equals to log 10x, that is equivalent to x equals to 10 to the y's power. And the second example is y equals to log ax here, that is equivalent to x equals to 8 to the y's power.